Thank you for joining me in this episode. I'm going to show you something that you may not have thought of before. We've practiced composing functions. What that means is taking a function and evaluating it within another function. We've done it numerically, we've done it abstractly. But what if I told you you could actually take functions apart? And I'm going to call that decomposing. So undoing the effects of a composition. So I have many examples set up for you. So this is the first of three-part series of videos I'm going to make for you. So let's look at the first problem here. So I have a function y equals radical x minus 3. So you can see it's a square root function. Now what if I told you you could actually break this up as two separate functions? In other words, it's been brought together by composing two functions. So what I want us to practice on is seeing that. So let's start to play with this a little bit. When you decompose functions, you want to think of what is the outermost function. In other words, what's the overall structure of this? So if you look at this, the overall structure of this is something that is being square rooted. What is the innermost function? In other words, what's inside? Do you see what's inside is a linear function, x minus 3. So we're going to call the outermost function f of x. And then we're going to call the innermost function g of x. This function here, the given function y equals radical x minus 3, can be thought of as f and g being composed. Well, the question is, which one is going inside, which one's going outside, what is the direction of the composition? So let's think about that. So this given function, square root of x minus 3, can actually be thought of as f of g of x. If you break f of x down as the square root of something and g of x as x minus 3. So you might be thinking, well, how would I check this, Stevenson? Well, let me show you. Remember with our compositions, this says take the g of x function and evaluate it into the f of x function. Well, according to my definition, I define g of x as x minus 3. So I'm basically taking x minus 3 and evaluating it into my f of x function. Well, what did I call f of x? The square root. So what this is telling me to do is take the square root of the input, which is x minus 3. And that is exactly what I was given. So I can thought of decomposing this as f of x as square root of x and g of x as x minus 3. Let's look at another problem. So here we have y equals 1 over x plus 2. So I want you to think for a moment here. What do you think the outermost function is, or the overall structure of this function is? And what do you think the inner or the inside function would be? So the outermost function I could see is a fraction. It's 1 over something. So again, you can name your functions however you want. So I'm going to say h of x is my outermost function. It's 1 over something. What is the innermost function? So when I say innermost function, what I'm asking you is what would you substitute into the overall structure to get what we were given here? Hopefully you saw that the innermost function would be x plus 2. So let's call this r of x. So we have our setup here. So let's look at how this problem breaks down. So I'm going to have my outermost function. So the overall structure is a fraction. So that's going to be h of x. Now what's going to go inside, or what's going to be h evaluating? Well, it's going to evaluate the x plus 2, which I'm calling r of x. So this is going to be h of r of x. And again, let's check. So h of, now r of x is x plus 2. So that means the h of x function says, hey, whatever you're evaluating, just put 1 over it and put it in the denominator. And notice, that's what I have right here. So when you decompose functions, what it is it's more of a mental exercise. So what I want you to do is start training your brain to look at a function and go, how would I compose this as 2 other functions or 3 functions? That'll be a different video I'll make. But you're looking at an outer and an inner function here.